Will be in English, so headsets are available. Let me begin by presenting a project I'm quite fond of because I'm involved in it myself, and it's, say, gvSIG in a different atmosphere. The presentation is called gvSIG Educa. Our next presenter, our next speaker is Álvaro Anguix. Thank you. This presentation has been produced by two people. We have Sergio Acosta from the Topographic Department in the government of Uruguay, and myself, but many have been involved in this project. gvSIG Educa, gvSIG Education in Spanish would be, is interesting. There might be some confusion because maybe some of you have read news about this project. gvSIG Educa is a generic name for any gvSIG application for education purposes. So gvSIG Batovi is a set of applications under gvSIG Educa, and it is addressed to the beneficiaries of the Uruguayan Ceibal plan. The idea is for students to use computers, and I think the speaker has said it's a low-cost computer, but I'm sorry, its English is a little bit poor and I couldn't understand. So let me give you a little background. This is a way of studying geography. Uruguay is a Latin American country. It was so boring to study geography. The Atlantic Ocean separates America, Europe, and Africa. It's boring and difficult to visualize. But apart from this information, which is what we used to study in school in the old days, there were some tools that came along, but they were complicated, and as you see on the screen, kids used to get bored to death. I love maps, but not everybody does. We've always seen world maps, and they did not allow for new data. You couldn't add information. Well, you could write on them and scribble, but we couldn't modify things or cross information. And if part of a country became independent or separated from the country, well, you couldn't actually introduce the change. This is not used in other countries, but this kind of plastic template was frequently used in Spain, and it was kind of useful to have these templates. You could actually learn the mountain ranges. You could do all sorts of things, but you couldn't modify, change, add. Then CAD programs came along, would allow us to visualize the information, but we couldn't cross data anyway, alphanumeric data, perform spatial operations, modify the representation of data. It didn't have an education nature at the end of the day. There are educational programs or software. We have K-Geography. It's used in Ubuntu. For instance, it allows for information to be visualized. It has an educational approach. It's game-like, but it does not allow it to change data, cross data, perform spatial operations, nor modify the representation of data. So, for instance, a question would pop up: where is Argentina? And you would click somewhere on the map, and if it would tell you if you clicked on the right country or not. Okay, there are online maps. We all know Bing, Yahoo, Google Maps, Google Earth, which allow us to visualize information, access global information, cross data. But again, there are some drawbacks. You don't have the freedom to perform advanced spatial operations like geoprocessing. It's not open source. You cannot adapt this application as one deems best, and we cannot change data. And we've seen frequently that often the data that's being provided are untrue. We have open source free online maps like OSM, OpenStreetMap. They allow for data visualization, crossing. They allow to add, modify changes, and distribute data. Also, as regards education softwares, it's interesting to have OGC services because this is increasingly available across the globe. This allows for information visualization, access, and data crossing, but you need a software like gvSIG, or platforms rather. Then we have geographic information systems, GIS. These data can be visualized, modified, crossed, and so on. But do these systems have an educational approach? Definitely not. It's quite a complex technology, and we saw that kid on the screen playing chess, like really wondering how to deal with the different pieces. Then the project Aegis project came along, and one of the main problems with this is that the GIS was pretty simple, allowed for simple assessments, but it cost £100. If we converted this, there are some 3 million students in primary education and 2 million in secondary education. So we're talking about some 600 million euro in licenses. Another initiative which is slightly cheaper, we're talking about $99 here. The project was called My World GIS, and this would make the bill fall, but still cost quite a lot of money. There have been free initiatives like Arc Explorer by ESRI. It had a light free GIS, but had numerous limitations. Information cannot be edited, and it has been replaced by the ArcGIS Explorer. that would be ArcGIS Desktop Explorer. And this technology has other constraints. I think in the third edition, during the third edition of this conference, a project called gvSIG was presented. This was conducted both in the region of Valencia and in La Palma, this island in the Canary Islands. It was a prototype, and they hoped that somebody would fund this, and it's taken some time for that funding to come along, and it has actually come from abroad. For the government of Uruguay, education is absolutely key, and they have decided to allocate funds, especially from the Ministry of Public Works and the Ministry of Education. Well, they decided to use gvSIG because it's free. I quote, because it allows for easy access. It doesn't have restrictions to application. It's again free of charge. So installing it is costs $0, €0, and it's a way of being a part of an international community. So this technology is consistent elsewhere in the world. There's also a consolidated local gvSIG community. The Uruguayan gvSIG community has been working for quite some time already, and comprised many individuals and government agencies. So there's a local support. So, in summary, the needs to have a software that could be adapted to all the different educational levels, meaning primary education, secondary education, so it should be easy to adapt. There should be no license cost, easy to use, user-friendly, and they thought that it should be open source. We'll see that GIS solves software problems. gvSIG is free, open source, and it was just only about taking on an educational approach or standpoint. So it's accessible, zero cost, collaborative, useful for the faculty and student body, and adaptable and consistent across the globe. Here you see two pictures. These computers are called Civalitas, something like that, and the green one is used in primary education, in blue, secondary education. So we had to produce two versions of gvSIG Batovi. There's a specific product for primary education and another one for secondary education. We reached an agreement with the government of Uruguay. Here you see the Ministry of Topography and Public Works. And that lady is a friend and colleague of ours that hasn't been able to attend the conference today. And this is a quote by Albert Einstein, a really smart guy. And he said, "If I can't draw it, I don't understand it." gvSIG Batovi is not only for educational purposes, but it can be used for social purposes, financial purposes. It can be used in social work. It can be adapted to different needs. It's not only about geography, but it includes interesting data from a natural science, social science point of view, to name a few. And an image is worth 1,000 words. So, what characteristic does gvSIG Beta V inherit from gvSIG? Well, access to local and remote data, uses OGC ISO standards, is easily extensible, adaptable, has a GNU GPL license available in different languages. It's easy to translate. It's available in numerous platforms. You see Linux, Windows, so on, and allows interaction with other softwares. The version for primary education is quite simple. It allows to consult cartography, thematic maps, allows enables interaction with the cartography through browsing, allows you to measure distances. It contributes with an interpretation of thematic maps using legends. You have here South and Central America, and you have color code, and anyway, there are some cartographic concepts that have been embedded. What about secondary education? Well, this is a gvSIG that has been specifically adapted to the computers I showed you earlier. The screen is small, and we have removed extensions that are not necessary for secondary education, certain rastering tools that make no sense, again, in secondary education, but we could include them again if necessary. It has a greater hardware power, but still a gvSIG can perform all sorts of analyses. It's user-friendly, easy to use, and it allows for a thematic map interpretation, and it generates a new type of documents that it's sort of an adaptation of a viewfinder, so you can label, scale up, scale down, and this can be converted to a thematic map. So you can actually decide the settings, and it would be something similar to this here. A map with tags, color code, and there's another benefit that thematic map can be converted to a gvSIG package. So this can be emailed, and students can share these files, and it's all included. So it's a wonderful way to share cartography among students of different high schools and schools, and even across countries. Furthermore, when we produced this application, we realized that it can be used via any gvSIG, this new thematic map functionality. So this enables generating thematics and sharing easily. So this data sharing is of the utmost importance for me. So it's no longer C, points slash, and the rest of the usual processes. This can also be used for other purposes, for heritage preservation, sites of interest. And this can be turned into a classic view. So it's a project that was born seeking to address educational needs, but can be actually used for many, many other purposes. These developments have been produced for gvSIG version 2.0 and includes 2 extensions, 1 for queries, 2 for sharing. I'm running out of time. In Uruguay, space for this project in Cibal was created. This project has been presented in numerous conferences and fora, and here you see some screenshots, and several countries have implemented this, including Venezuela, Panama, and ICA is translating all of the contents into English and giving a hand as regards dissemination. So here you have a quick snapshot. It explains a little bit what it's all about, and everything is almost a plug and play. And here you see something that was published yesterday. So in the outreach website, there is a section to share thematic maps. So if you want to share a map with someone, you just have to fill in a little form, do a screenshot, indicate the server, and that's it. So you can use even physical maps, but this has a wonderful potential for the education sphere. It's useful for teachers and students. It has the UN and World Bank code, so this is really helpful if you think about it. Remember a workshop in Uruguay on access to drinking water, children mortality. So these maps were no longer simple, but could be used to perform a data analysis at a whole different level. And in one of the workshops, one of the teachers who wanted to learn about this software came with her 11-year-old daughter because she feared she would not be able to find her way around this software. This is my last slide. So you see here all the benefits, including accessibility, low cost, but it also has to do with values. It conveys the value of sharing. As for future perspectives, we are working on empowerment and capacitation, dissemination, and building new tools. This we've done in Uruguay can be used in other countries, and personalizing it is very simple. Thank you so much for your kind attention.
Muchas gracias, Álvaro, por presentarnos este gran proyecto. Tendremos que ir pensando en organizar las jornadas.
So we have to organize a conference for children. I will bring my kids. I don't know if you have any question in the room or we go straight to the next speech. Yes, much better like that.